Bismillahirrahmanirrahim. Assalamu alaikum viewers. P. Khizra Bibi Muhammad Fayyaz, student of MSc Final Year Chemistry, would like to thank my respected teachers, Professor Dr. Nasreen Fatima, Dr. Shazia Nisar, Dr. Asad Khan Tanoli, and Dr. Sadaf Iqbal for giving me this opportunity to portray my talent regarding my presentation topic, that is analysis of water for total suspended solids, total dissolved solids, and total cations. Presentation points. What is water analysis? Theory for total suspended solids, total dissolved solids. What cations are present in water? Procedure, observations, and calculations. Requirements for this experiment are 50 ml water sample, analytical balance, Whitman filter paper, evaporating dish, filter membrane along with vacuum pump, wash bottle, forceps, dish tongs, measuring cylinder, and drying oven. Before talking about water analysis, why do we need to analyze water? If water is badly polluted like raw sewage, it may be obvious from its appearance or odor. It may be colored or turbid, cloudy or have solids, oil or foam floating on it. What is water analysis? A chemical analysis of the dissolved materials in water, including a determination of the amount of suspended solids and the pH value. Total suspended solids. Total suspended solids include all the particles suspended in water which will not pass through a filter. Environmental significances of total suspended solids are: suspended solids absorb heat from sunlight, which increases water temperature and subsequently decreases levels of dissolved oxygen. Warmer water holds less oxygen than cooler water. Suspended solids parameter is used to measure the quality of wastewater effluent and influent. Suspended solids determination is extremely valuable in the analysis of polluted waters. Now, total dissolved solids. It is defined as residue upon evaporation of filterable sample. Environmental significances of total dissolved solids are: estimation of total dissolved solids is useful to determine whether the water is suitable for drinking purpose, agriculture, and industrial purpose. High concentrations of dissolved solids, about 3000 mg per liter, may also produce some distress in livestock. In industries, the use of high amount of dissolved solids may lead to scaling in boilers, corrosion, and degraded quality of product. Differences between total suspended solids and total dissolved solids. Let's have a look at them. Total suspended solids are the amount of solids that are not dissolved in water sample, whereas total dissolved solids are the amount of solids that are completely dissolved in water sample. Total suspended solids are non-filterable in nature, whereas total dissolved solids are filterable in nature. Total suspended residues contains large enough size particles, whereas total dissolved residues contains smaller particles along with ionic species. Total cations in water. This chart containing the cations which are present in water: hydrogen ion, sodium ion, potassium ion, ammonium ion, silver ion, calcium ion, iron 2 ion, copper ion, lead ion, iron 3 ion, and aluminum ion. Other major ions in water are sodium. Its high level often associated with pollution. Potassium, its concentration generally low, that's less than 10 in natural fresh water. Whereas bicarbonates concentration normally ranges from 25 to 400 mg per liter. Carbonates in fresh water is normally diluted. Its concentration is less than 10 mg per liter. Whereas sulfates concentration normally in between 2 to 80 mg per liter. And chlorides concentration normally less than 40 mg per liter in unpolluted water. Determination of cations concentration. Cations concentration usually are determined by atomic absorption spectroscopy AA method or inductively coupled plasma emission spectroscopy ICP method. In AA and ICP analysis of saline waters, dissolved salts can cause significant interference, so it is always a good idea to check analysis for reliability. What is anion-cation balance? One useful method for determining the reliability of major ions analysis of fresh water or saline water is measurement of anion-cation balance. This method assumes that major ions comprise most of the total dissolved solids in a water sample and requires that all the major ion concentrations are measured. Moving towards the procedure, for suspended solids. In the first step, empty Wattman 40 filter paper was weighed. Then, this 50 ml of water sample was pipetted out. The 50 ml water sample was filtered through this dried and weighed filter paper. In the next step, insoluble substances on the filter paper was washed with 20 to 30 ml distilled water. Then the filter paper was placed in oven to dry at 100 to 110 degrees centigrade. In the last step, filter paper was cooled and its weight was noted from balance. Moving towards the another procedure for dissolved matter, its first step is clean, dried and empty beaker was weighed. Then the filtrate which was collected from suspended water was cooled and transferred into weighed beaker. Then the beaker was placed at burner and filtrate was evaporated carefully to just dryness. Beaker was placed in oven to dry at 100 to 110 degrees centigrade. But in the last step, beaker was cooled and its weight was noted from balance. Observation data collected for the total suspended solids. Weight of clean Wattman filter paper obtained is 0.8406 gram denoted by W1, while the weight of filter paper and suspended solids residues is obtained 0.8446 gram denoted by W2. Volume of water sample taken 50 ml. Observation data for the total dissolved solids. Weight of empty clean beaker is 131.6044 gram denoted by W1, while the weight of empty beaker and dissolved matter denoted by W2 was obtained 131.6255 gram. Calculations for total suspended solids. Weight of suspended solid obtained by subtracting the weight of empty filter paper from the weight of filter paper and suspended solids. By subtracting them, it obtains 0.004 gram. But this gram was converted into milligram to obtain results in ppm by multiplying by 1000. 0.004 multiplying by 1000 becomes equals to 4 milligram. Then this milligram was obtained in 50 ml water sample. So by dividing this 4 milligram by 50 ml, it becomes equals to 0.08 milligram per liter. As the volume of sample is in ml, so to convert this ml to liter, multiplying this value by 1000, it becomes equals to 80 milligram per liter. As 1 milligram per liter is equals to 1 ppm, so this 80 milligram per liter is equals to 80 ppm. Hence, the concentration of total suspended solids is equals to 80 ppm. Now the calculations for total dissolved solids, in which the weight of dissolved solids obtained by subtracting the weight of empty beaker from the weight of empty beaker and dissolved solids. By putting their value, we found weight equals to 0.0211 gram. This weight was obtained in gram. So multiplying by 1000, it's converted into 21.1 milligram. But this weight was obtained in 50 ml of water sample, 21.1 milligram per 50 ml. By dividing them, it's become equals to 0.422 milligram per ml. Volume of sample is in ml, so to convert this ml to liter, multiplying this value by 1000, it's become equals to 422 milligram per liter. This 1 milligram per liter is equals to 1 ppm, so 422 milligram per liter would be equals to 422 ppm. So the concentration of the total dissolved solids obtained is equals to 422 ppm. Now moving towards the results. Found for the concentration of total suspended solids is 80 ppm, while the concentration of the total dissolved solids found is found 422 ppm. So this was all about from my presentation. Thank you so much, viewers.